Math 8, Unit 6, Pythagorean Theorem in Real Numbers, Lesson 7, Adding Radical Expressions. Now first, we need to remember adding like terms. We learned this in 7th grade, and we have used it a bunch continuously since then. So, first, what is 12g plus 9g? Now, these are like terms, so 12g plus 9g we can treat as 12 plus 9 times g. So this will be 21g. 11x plus 9 minus 7. We can only combine the pieces together that are like terms, which is the 9 minus 7. So the 11x doesn't change, and 9 minus 7 is 2. So this ends up being 11x plus 2. All right, example 14, 8s minus 11s plus 6. We can take these like terms, 8s minus 11s, and subtract their coefficients, or add their coefficients technically. 8 and negative 11 make negative 3, and then the plus 6 didn't change. Okay, next one, number 15, 4.2v minus 5 minus 6.5v. The 4.2v and the negative 6.5v are like terms, so we can combine them together. 4.2 minus 6.5 gives us negative 2.3v, and then we'll subtract the 5, and that will be it for number 15. Okay, number 16. Look for like terms. We've got the 4a and the negative 9a, which together make negative 5. 4 minus 9 is negative 5. And then we've got the 8 and the plus 6.2, which make 14.2. So you get negative 5a plus 14.2. And there are more examples here, but I think I'm going to go ahead and move on. That's the idea, that you can add like terms together. So continuing from the last lesson, you can add radical expressions by adding like radicands. Example, 2 square roots of 2 plus 5 square roots of 2 will be 7 square roots of 2. It's just like you're doing 2x plus 5x, or 2 halves plus 5 halves. It's like common denominators as well. So you can add common radicals. Each radical term can be simplified individually before adding like radicals. So simplify each expression. We've got 4 square roots of 3 plus 6 square roots of 3 minus 5 square roots of 3. Because every one of them is a square root of 3, we can add them together. 4 plus 6 is 10, minus 5 is 5. So this will simplify down to 5 square roots of 3. Does the square root of 3 simplify? Well, there are no perfect square factors that go into 3, so it doesn't simplify it. All right, example 5. 12 square roots of 5 plus 3 square roots of 7 plus 6 square roots of 7 minus 8 square roots of 5. We can only combine like radicals together. 12 square roots of 5 and negative 8 square roots of 5 make 4 square roots of 5. And then 3 square roots of 7 and 6 square roots of 7 make 9 square roots of 7. And there's nothing more I can do to simplify this down, because 5 is simplified, there's no squares that can go into 5, and 7 is simplified, there's no squares that can go into 7. Okay, 5 square roots of 11 minus 14 square roots of 13 plus 6 square roots of 13 minus 11 square roots of 11. Again, like terms can be combined. 15 and negative 11 make 4, so 4 times the square root of 11. Negative 14 and 6 make negative 8 square roots of 13. 11 has no perfect square factors, and 13 does not either, so this will not simplify down any further than that. 3 square roots of 2 minus 5 square roots of 2 plus the square root of 2. Well, these are all square roots of 2, so 3 minus 5 is negative 2, plus 1 is negative 1. So this simplifies down to negative 1 square root of 2, or just negative square root of 2. And since 2 does not have any square factors, that is already simplified. Example 6. Simplify 2 square roots of 20 plus 3 square roots of 45 plus the square root of 180. Now this one, none of the radicals are the same. So we might be done, except for the fact that these radicals can be simplified. 20 is 5 times 4. 5 is prime. 4 is 2 times 2, both of which are prime. 45 is 9 times 5. 9 is 3 times 3. And 180 is 18 times 10. 10, of course, is 2 and 5. 18 is 9 and 2. And 9 is 3 and 3. So each one of these needs to be simplified individually. 20 is 2 times 2 times 5. 45 is 3 times 3 times 5. And 180 is 2 times 2 times 3 times 3 times 5. Okay, simplifying this down, I already have a 2. I can pull out another 2, and I'm left with a 5 inside. On the next one, I already have a 3. I can pull out another 3, and I'm left with a 5 inside. The last one, I have a 2 I can pull out, and a 3 I can pull out, with a 5 left on the inside. This gives me 4 square roots of 5, plus 9 square roots of 5, plus 6 square roots of 5. After doing that reducing, these are all square roots of 5. Since they have the same radical, we can add 4 plus 9, which is 13, plus 6, which is 19. This reduces to 19 times the square root of 5. So sometimes you will have to break down and simplify the square roots before you can combine them together. Okay, let's go over these quick examples and then a couple more. Simplify 8 square roots of 5 plus 3 square roots of 5. Well, since they're both square roots of 5, you can just add them and get 11 square roots of 5. No problem there. Same with number 12. 3 square roots of 6 plus 10 square roots of 6 is going to be 13 square roots of 6. The square root of 6 is just 2 times 3. There's no pairs. Number 13, 2 square roots of 15 minus 6 square roots of 15 minus 3 square roots of 15. That's going to be 2 minus 6, which is negative 4, minus 3, which is negative 7, times the square root of 15. The next one, these are all square roots of 19. 5 plus 6 minus 11 is 0. 0 times the square root of 19 is just 0. We don't need the square root of 19 because it's multiplied by 0. 8 square roots of 3 excuse me, minus 2 square roots of 2 plus 3 square roots of 2 plus 5 square roots of 3. 8 and 5 are both square roots of 3. They make 13 square roots of 3. Negative 2 and 3 make 1. So we get 1 square root of 2. Next example. Square root of 6, square root of 2, and square root of 17. Well, 6 doesn't reduce, and 2 doesn't, and neither does 17. But the two 17s can go together. 1 plus 4 is 5. 5 square roots of 17, plus the things that couldn't reduce. 4 square roots of 6, and negative 6 square roots of 2. And that is simplified all the way down. Okay, the next ones here need to be broken down. 18 is 2 times 3 times 3. 12 is 6 times 2, which is 2 times 3. 12 is 2 times 2 times 3. And 8 is 2 times 2 times 2. We can actually pull this out and get 3 square roots of 2 plus 2 square roots of 3 plus 2 square roots of 2. And the square roots of 2 can add 3 square roots of 2 plus 2 square roots of 2 is 5 square roots of 2, and then plus 2 square roots of 3, and that is all simplified down. Okay, the next one. The square root of 6 doesn't reduce, neither does 3, but 12, we actually already know 12 from right here. It's 2 square roots of 3. So this is 2 square roots of 3, which can be combined with the other 2 square roots of 3 to get square root of 6 plus 4 square roots of 3. Okay, right here 7 doesn't reduce down, but 28 is 7 times 4, a couple of 2's there. So this is 2 square roots of 2 times 2 times 7. And we pull out a 2 and multiply it by the 2 that's already there. So this is 3 square roots of 7 minus 4 square roots of 7, which is negative square root of 7. 3 minus 4 is negative 1. Okay. The square root of 50. 50, that looks like 80. The 50 is 5 times 10, 2 times 5. So this is 2 times 2 times 5 times 5. 2 times the square root of 2 times 5 times 5. You can pull the 5 out. That is 10 square roots of 2. And 32 breaks down into 8 times 4. 4 is a couple of 2's, and 8 is 3 2's. So this is 3 times the square root of 2 times 2 times 2 times 2 times 2. There's 5 of them in there. We can pull out 2 sets of 2's, and this is minus 2 times 2 times 3, that is 12 square roots of 2. 10 minus 12 is negative 2 square roots of 2. All right, one more example, I believe, and then we'll preview the assignment. Determine the perimeter of the triangle. Give answer in exact decimal form. Well, to get the perimeter, we need to know this side length here. So we'll use the Pythagorean theorem. 6 squared plus the square root of 12 squared equals c squared. That's 36 plus 12, which is 48, equals c squared. So c is the square root of 48. So the perimeter here is going to be the square root of 12 plus 6 plus, let me change that, I'm getting a little ahead of myself here, plus 6 plus the square root of 48. Now 12 and 48 can be factored. So 12, of course, is 2 times 2 times 3. And 48, well, that's 6 times 8. 6 is 2 times 3. And 8 is 2 times 2 times 2. So 12, 2 times 2 times 3. I'm going to put 6 out here at the end. And 48 is 2 times 2 times 2 times 2 times 3. We can pull out a set of 2's. That's 2 square roots of 3. We can pull out a couple sets of 2's. This is 4, of course. 2 square roots of 3 plus 4 square roots of 3 is 6 square roots of 3. And then plus 6. That will be our perimeter. 6 square roots of 3 plus 6 units. Okay, let's preview the assignment. In the assignment, number 1, you're going to be practicing adding radical expressions. Sometimes you'll have to reduce them first. Number 2, determine the perimeter of each square. I want you to give these an exact radical form as well. Number 3, find the area of that square. 4, you're going to review graphing. 5, a review of solving equations. 6, a review of transformations. I give you a transformation on the left graph. I want you to complete that same transformation on the right graph. Number 7 introduces you to the idea of simplifying cube roots. And number 8, you're going to find the perimeter of that hexagon. You're going to have to use the Pythagorean theorem a few times to find the length of y and the length of x, so that you can find the perimeter by adding all of those lengths together.